This is part D of lecture 6 on Descriptive Statistics and Islamic Approach. In this portion, we will deal with how the distribution of infant mortality has changed over time. This is a type of a stochastic relationship that we studied in a previous lecture. The question we want to study is, how did infant mortality change over time? Now we can study this on a country-by-country basis. The World Development Indicators WDI dataset has data for a large number of countries. Here is a plot of how the infant mortality changed in Bangladesh over time. In 1960, it starts at 173 and declines to 25 in 2017. In a similar way, we can use the data to plot this graph for any country. But this is not what we are looking for. We're not looking for individual countries. We want to look at the distribution of infant mortality over all of the countries. And this is a different concept. We are actually looking at how the distribution of infant mortality change over time. This is a stochastic relationship where we want to study the evolution of the distribution as time changes. It is important to clearly differentiate between the distribution and the individual countries. And the data for any group of countries doesn't give us the distribution. Distribution comes from looking at the infant mortality in all of the countries together. The distribution will not give us information about any single country. We cannot go from individual cases to the distribution and cannot go from the distribution to individual cases. The full distribution is in the histogram, more accurately the mathematical empirical distribution function, which responds to every single country, but that's a concept we will delay for later because it is technical. The summary of the distribution is in the 5 quartiles, Q0, Q1, Q2, Q3, and Q4, which we have studied before. Q0 is the minimum and Q4 is the maximum, and Q2 is the median, and Q1 and Q3 are the first and third quartile. Quartiles provide a snapshot summary of the distribution. So here is an illustration. This is the infant mortality distribution in 1960. It looks at all of the countries for which there is data, and the minimum infant mortality in 1960 was 16.3 and the maximum was 222. Between all of the quartile lines which are drawn on this graph, we have 25% of the country. So this tells us something about the distribution of the countries in this range from 16 to 222. From 16 to 57, we have 25% of the countries. From 57 to 105, we have 25%. And then from 105 to 140, we have 25%. And then we have a large tail going from 140 to 220, where there are 25% of the country. So this tells us about how the countries are distributed across this range of infant mortalities. It doesn't tell us anything about any single country. The distribution does not tell us which country had the smallest infant mortality and which country had the largest, although we can go back to the data set and figure it out. The distribution is a difficult concept to actually grasp fully. It's a little bit technical, but as a first approach, you can think of it as the 5 quartiles, as a first approximation, and it tells us where the countries lie, all of them together. It does not identify which country is where and which are the best 25% and which are the worst 25%, although it tells us the range which is occupied. And the reverse is also true. We can have individual country data for every single country, but even that is not enough for the distribution. We have to arrange the countries in order and then look at the ranges which are occupied to figure out the distribution from the individual data. Look at how the infant mortality has changed over time. And here's a first point and last point picture. In 1960, we've already drawn the 5-point summary. This graph also gives the 5-point summary in 2018. And you can see that there has been a dramatic change in infant mortality over this period of time. The best quartile in 1960, the best 25% of the countries had infant mortalities ranging from 16.3 to 57.3. But now the best 25 countries are at 1.4 to 6.1. The worst quartile was 139.4 to 222, and now it goes from 32 to 84. That's a dramatic change. It means that even the worst countries, the worst 25% of the countries, have dramatically improved in terms of infant mortality. So the issue is, how did this happen? What was the cause of this change? We call the fundamental questions of real statistics. Why are we studying infant mortality? Well, death of children is an extremely important life event. It causes huge amount of stress for the family, and families spend huge amounts of money to try to save their children. It causes trauma for many. So it matters. So we want to study infant mortality because we want to see if they can change things, if we can change things by learning more about it. So what does infant mortality number mean? What does it mean to say that infant mortality was 222? Well, basically the number is supposed to measure, you have 1,000 live births within, and then you trace these children to make sure they live for 1 year. Any child that dies within the first year is considered as a mortality. So if you have 200, that means of 1,000 children who were born, 200 children died. And if you have 1.5, that means of 1,000 children who were born, 1.5 died, or more without fractions. Of 2,000 children who were born, 3 children died. So that's virtually nothing. It means that the data show that child deaths can be virtually eliminated. How do we compute these numbers? Well, this varies from country to country. You can, in countries where every birth is registered, it's easy to follow the status of children. In other countries like Pakistan, where births are not registered, we do surveys and take samples and make guesses. And this may often be an underestimate because the population that is most at risk is not does not fall easily into a survey. Anyway, what will we do with this analysis? Well, basically we're trying to understand the causes of high infant mortality, which we have in Pakistan, so that we can take the right policies to remove these causes. We come back to the stochastic distribution. How has the distribution changed? We will take it step by step. So we look at the median of the infant mortality among all countries in the WDI dataset. And this is the picture of how the median has changed. And we can see that it has declined smoothly from 106 at its start at 1960 to only 14. That's a huge reduction, and this is widespread over all countries. So this the median number divides the country into two parts. So the median of 14 means that in 2018, 50% of the countries had infant mortalities at 14 or less. On the other hand, 50% of them had 14 or more. So this is sort of a center of the infant mortality. If we want to compare whether a country is good or bad, whether it's above average or below average, this is the number to look at. Countries below 14 are better than average, and countries which are worse than 14 are worse than average. So now it's clear that infant mortality has declined across the board. The question is why? One of the factors that might be the case, and we will study later, is that there have been more in-hospital births. This is known to be an important factor in reducing infant mortality. On a comparative note, we will always use the median as the center of a distribution. This is the best one number summary of the distribution. Standard stats texts use the mean and the best one number summary. This is true if the data is normally distributed, but most data in fact is not normally distributed. The mean does not have any natural interpretation, but the median does. It tells us, if you know the median, that half countries are below and half of the countries are above. By looking at the big picture, we sometimes learn about the micro picture. This has happened often in statistics. For example, when people saw a very rapid rise in a very rare type of lung cancer, they wondered why it was so. And then they looked at the data and they saw that this rise corresponded to a rise in the spread of cigarettes. And so they put two and two together and said that probably cigarettes are causing this. And then there was a huge battle. These days, the same battle is taking place between sugar and diabetes. The sugar industry has managed to put sugar into all the foods that we eat, and this has caused a massive health effect in terms of people having sugar-related diseases, among which is diabetes. And the sugar industry is fighting a battle to prevent the public from finding this out, and they're claiming all the heart attacks and everything is due to fats, whereas in fact it seems likely that sugar is the culprit. So the knowledge that statistics gives us is of great value commercially and politically, and battles are being fought always over this knowledge. It gives us only the center of the distribution. It doesn't characterize the range of the distribution. So we'll now look at the mid-range or the middle half of the data. This lies between Q1 and Q3, the first and the third quartile. This is plotted in this picture. So this picture also has a natural interpretation. The area between Q1 and Q3, the blue and orange lines, has 50% of all the countries in WDI. Then about 25% lie above the orange line and 25% lie below the line. Now if you look at what these numbers are going from 60 to 2018, in 60 the mid-range was between 57 and 140. And this has gone down to between 6 and 33. Again, a massive reduction. And these are the middle half of the countries, not the exceptionally good ones, which are the bottom 25%, and not the exceptionally bad ones, which are the top 25%. So you can see that on the average across all the countries, there has been a massive reduction in infant mortality. And 25% of countries today have infant mortality less than 6, and 50% are between 6 and 33, which are fairly decent numbers. For Q1, Q2, and Q3, the middle three quartiles. Now we look at the minimum and the maximum, Q0 and Q4. Here the maximum dominates the picture. We see that it actually went up for a little while, has generally been declining, but there are a few bumps. The maximum is very sensitive. Just one country which has a war and has high infant mortality will increase the maximum. So maximum doesn't really show us the general trend. Maximum can remain high even if most of the countries are doing very well. But here we see that the maximum is going down. This means that even the worst possible country is doing well. It has gone from up to 20 to less than 100. So the infant mortality has been cut by a half even in the worst case country. Now one important thing to note here is that the scale of the graph is very important. Here we are plotting the maximum and the minimum hardly shows any change. This is because when we are graphing in the level of 200 and 250, then the small changes in the minimum just get reduced to nothing, as we will see in the next graph where we plot the minimum separately. Look at the minimum infant mortality across all the countries. And this is shown by this graph. As you note, this goes from 16 to about 1.4. When you plot it separately, then the scale is very clear that there has been a dramatic increase in infant mortality. It's not drowned out by the maximum graph. So this shows that there have been dramatic improvements. The best possible cases are really very good. 1.4 infant mortality, that's about 3 children in 2000, is really very, very low. It means that with the right type of medical care, we can save almost every child who is born. So how can we do this? This requires learning more about the causes of infant mortality, and this requires what famous statistician David Friedman called shoe leather. You can't learn about this by looking at these graphs. You have to go into the real world and look at why infant mortality happens. You have to go into the hospitals and you have to go into the villages to see what's happening and how children are born and why they die in order to discover this. This is one of the key features of real statistics, that we don't believe that data by themselves, the numbers by themselves, can teach us about the real world. We have to look at data in conjunction with the real world. Can we learn more about causes? Well, there are many ways. One is an external data-based approach. If we have more data on timing, you find out that deaths within 1 week of birth, within 1 month, and within 1 year have different causes. The early deaths are due to no prenatal monitoring, no micronutrients given to the pregnant women, and also basic mismanagements of birth. Very simple, very easy to fix problems that occur and nobody knows how to solve them. There's basically an 80-20 rule. 80% of early deaths, mother and child, are easily preventable. There's no fancy technology required. One doesn't need advanced medicine. One just needs simple basic knowledge. So how do we get this? How do we make this change? Well, it turns out that it's not just a question of making techniques available. You have to also get people to accept this and to consider that to change the social norm. For example, it's quite common in Pakistan that when women are about to deliver, they are taken back to the rural areas because people fear that hospital births will end up costing, and they may have other superstitions and fears. We have to change this attitude, and we have to, an example is that of Cuba, which has the best health system, even though it has very minimal resources. It's not one of the richest countries at all. In fact, it's quite poor relative to economics, but it has done a tremendous job in terms of its health systems. In this final slide, we look at the process of how we learn about the world through numbers. First, we note that numbers are not collected arbitrarily. Somebody believes in something, normally some theory about the world, which leads him to gather data on a particular set of variables. And also these theories tell us what is important and what is not. So what is important, that data is gathered, and what is not considered, that is not collected. So once we study the data with a view to understanding the real world, this leads us to questions, the questions which cannot be answered by the data. And then we formulate tentative hypotheses. For example, we thought that maybe in-hospital births is one of the reasons for the decline in infant mortality. So we need, in order to test this hypothesis, we need to collect more data. We need to go out and see how many in-hospital births there have been. If the in-hospital births have increased at about the same rate that we see that the infant mortality has gone down, then we can say that, okay, we've got the answer. It's all about in hospitals. But if they have increased somewhat, so they explain some part of the decrease, but not other parts, and that's how actually it turns out, then we can just say that in-hospital births is one part of the solution, but there are other other factors which are also important. So when we formulate hypotheses, then we can go out and collect data. So this is an iterative process. We have theories lead us to collect data, analysis suggests hypotheses about how the world works, and to test these hypotheses we go out and collect more data, and from the data we get more hypotheses, and so on. The data might confirm our hypothesis, it might disprove it, Once it disproves it, then we generate more hypotheses, and so on. So it's an iterative process, and this is something which is not taught in conventional statistics, which says that it's all about the data. So you look at the data which has been delivered to you, and you analyze it, and you stop.